Howdy, our team name is Team Trees, and today we are presenting our biomimicry design proposal focused on reforestation. My name is Brian. I worked on the formatting and our research for our UN 17 goal.
Howdy, my name is Bisma, and I worked on formatting and researching real-world issues to establish our problem statement.
Howdy, my name is Sohail, and I worked on researching and finalizing our design.
So, for our table of contents, first we're going to take you through the ecological context that we found made it necessary to explore this field and solutions for the issue we identified. Then we went and looked for aligning UN 17 goals for this problem statement, and then we're going to establish what that problem statement was. Then we're going to move on to brainstorming ideas and solutions that we came up for the issue that we found. And then we're going to go into a finalized design based off the UN 17 goal of our choice. And then finally, we're going to go into the EDP or the engineering design process that we use throughout this project.
Okay. Before designing a solution, we first examine the ecological context of the problem. Deforestation is currently occurring faster than forests can naturally recover. Forests are extremely important because they regulate Earth's climate by absorbing carbon dioxide. When forests are cut down or burned, the carbon that was stored inside those trees is released back into the atmosphere, which accelerates climate change. According to global forestry reports, around 10 million hectares of forests are lost every year, which is roughly the size of Korea. This rapid loss of forests makes replanting efforts essential.
Yeah. For aligning UN 17 goals, while developing our design, we just considered the environmental impact of our solution and how it could align with sustainability goals outlined by the United Nations. After reviewing the UN Sustainable Development Goals, we selected the two that best connect to our project, looking at climate action and responsible consumption. Our biomimicry inspired system focuses on increasing the efficiency and scale of tree planting to help address deforestation, while also supporting responsible consumption and production, SDG 12, by ensuring the materials used in our design have a net positive environmental impact. These goals helped guide our design process and lead directly into the problem our project aims to solve. So therefore, we chose responsible consumption, as you'll see in the problem statement, and applies directly to deforestation is occurring faster than forests can naturally recover, and current restoration methods are not sustainable at the scale required. Manual planting is slow, costly, and limited by terrain, while traditional aerial seeding results in low survival rates and significant resource waste. Under the goal of responsible consumption, how can forest restoration be made more efficient, scalable, and resource conscious to support long-term ecosystem recovery?
To answer this question, we brainstormed several different biomimicry-inspired concepts. Our first idea was a nestor drone inspired by the behavior of the Clark's nutcracker. This bird naturally stores seeds underground at optimal depths, which helps many of them successfully germinate. Our concept used a drone with pneumatic planting mechanisms to replicate this behavior and precisely place seeds into the soil. Another concept was the bird drone. The idea was to design drones that mimic bird flight patterns and distribute seeds across landscapes in ways that align with natural ecosystem processes. We also explored a windmill dispersal system, which uses solar-powered windmill to help disperse seeds while improving airflow and local climate conditions to support early plant growth. The planter rover was a slow-moving autonomous ground vehicle designed to travel across terrain planting seeds while monitoring environmental conditions. The supertree concept focused on selecting or engineering more resilient seeds that could survive harsh environments and in distributing them using aerial planting systems. Finally, the environmental pole was a solar-powered structure designed to regulate shade, airflow, and other local conditions to improve survival rates for young trees.
As shown below, to decide which concept was most promising, we created an evaluation matrix using what we considered the most important criteria for this problem. Those were time efficiency, materials required, feasibility, cost, and the environmental impact. Each design idea was scored based out of 100. The better the design was for this criteria. For example, in time, the Nestor drone is 20 out of 100, meaning it's a faster solution compared to the plant rover, which is 10 out of 100. After comparing all options, we were able to determine that the Nestor drone concept scored the highest overall, meaning this design showed the greatest potential to significantly increase planting speed while still being feasible cost-wise.
Our final design is called a nestor drone. The concept is inspired by the natural seed nesting behavior of birds like the Clark's nutcracker, which stores seed underground and unintentionally helps plant new trees. First, looking at time, the nestor drone can plant seeds more than 10 times faster than manual labor. Increasing the planting speed helps reforestation efforts keep up with the current rate of deforestation. Second is cost. While drones have a high initial investment, studies show drone planting systems can be about 80% more cost-effective than traditional manual planting. This allows large forest restoration projects to be completed at a lower overall cost. Third is feasibility. The technology required for this design already exists. Drones, pneumatic planting, mechanisms, LiDAR, and seed pods are all currently used in different industries, which means the system could realistically be developed and deployed. Fourth is material use. Our design focuses on using sustainable or recycled materials whenever possible. The goal is to ensure that the drone system itself supports responsible production while helping restore forests. Finally, the environmental impact is significant. By planting resilient trees at a much faster rate, the Nestor drone can help restore forests, matching the pace of deforestation. This slide shows a visual representation of our concept in comparison with how the Clark's nutcracker stores its own seeds before burying them. Our nutcracker nester drone mimics the natural system almost step by step. Just like the nutcracker gathers seeds in its throat pouch, our drone carries multi-species seed pouches designed to mimic the same efficient storage. The bird uses sharp visual memory to map landscapes. Our drone mirrors this with LiDAR and spectrometer vision, allowing it to scan terrain, identify viable planting zones, and build a spatial memory map in real time. When a nutcracker plants seeds, it uses its beak to push them deep into the soil at the right depth. Our drone replicates this behavior with a precision pneumatic planting arm that mimics the bird's beak action.
Okay, and finally, to go over the EDP or the engineering design process that we went through as we completed this project. First, we identified our ecological problem, that being deforestation outpaces natural forest regeneration. Then we evaluated it against the different UN 17 goals and found that responsible consumption to improve restoration efficiency and reduce resource waste best aligned with the ecological problem. So from there, once we had our narrowed field, we were able to come up with a problem statement. How can forest restoration become scalable, efficient, and resource conscious? Once we had this problem statement, we were able to go into the brainstorming phase. We generated multiple concepts such as drones, rovers, environmental supports, and resilient seeds, all aiming to solve tree resilience and growth. With all these ideas, we needed to find which one was best, so we put them into the evaluation matrix, where we evaluated the ideas on cost, impact, feasibility, and more. Um, Once we had found that the Nestor drone had, in fact, the highest score, we went into the initial design, where we developed a biomimetic drone with precision seed planting mechanism. But with this design, we were able to identify some issues. We had to address challenges in the seed depth, power use, and terrain adaptability. Finally, we went into redesigning and finalizing the design by improving the structure, the materials, and the planting efficiency to go and solve those issues. Throughout this project, In all, by researching how natural systems efficiently disperse seeds and adapt to different environments, we developed a concept that combines biological inspiration with engineering design. The Nestor drone aims to increase the speed and efficiency of reforestation while reducing the labor and time traditionally required for large-scale tree planting. These were our resources, as you'll see cited throughout the presentation, and thank you for listening.